Hi everyone. In this video, I will be showing you what is the relation between GitOps and Argo CD and how to deploy an application using GitOps methodology and using Argo CD tool to Kubernetes clusters. So before proceeding with the video, let's understand what is GitOps. Let's assume there is a project, any project, and if this project needs some application code and then infrastructure. Okay, so this is built by some people and this is built by some people. What GitOps will try to do is whatever methodology you are trying to build this application code, it assumes that everything is showed in Git. It may be GitHub, GitLab, or Bitbucket, or any other thing. And if a project completely want to go with GitOps methodology, then not only the app code, even the infrastructure code, like any ISC code, should also be in Git. Then only we can say that this complete project is following GitOps methodology. I'll be more clear. Let's assume there is a front end and back end code. So this is the final server. So whatever code is there in this Git repository, if the same code is in the server without any modifications, then we can say that this is using GitOps methodology. If you know Kubernetes, then if the replica count of a deployment is 2 and the image tag is v2 and the same thing is there in the Kubernetes cluster, then it is following GitOps methodology. So GitOps doesn't mean that you have to use only Kubernetes. It can be anything, any physical server, VMware, virtual machine, or EC2 or Kubernetes, anything. Just GitOps means whatever code is there in the Git, it should be there in the end server. This is the first thing. Now coming to Argo CD. Why we want to use Argo CD? Before going to Argo CD in detail, let's take a step back and explain what are the issues we are facing without Argo CD or Flux or any other tool. I'll be taking one path. I'm using a user machine and it will go to GitHub and then any CI tool. Let's assume Jenkins here, and it will create the image in Docker Hub after all the steps. So once the image is created, then again there will be one more step in the Jenkins where it will push the same new image, whatever it's been uploaded to Docker Hub, to K8s. So here we have two issues. This is the most two factors which helps in using Argo CD and which makes us to use Argo CD. First one is this CI tool has complete access to the Kubernetes cluster. It may be Jenkins or anything. It has complete access to Kubernetes. So if a person who logs into Jenkins and has admin access is indirectly having admin access to Kubernetes. Second thing, if a person logins to or get an access to Kubernetes cluster and he changes something, maybe he updated the image tag by mistake or a replica count from 1 to 11 or anything, and it will change the desired state. So with this change, we don't know who has access to this machine and who made the changes and what caused the issue. There is no point to note that what exact changes were made and how to revert it back. These two high level issues made most of us to use tools like Argo CD and Flux. Argo CD helps us to fix this issue. Let's see how. Again, I'll take the same path. User pushes to GitHub and then goes to Jenkins and then to Docker Hub. Now here is the Kubernetes cluster. Now once the image is pushed to Docker Hub, that's the complete CA part. It's completed. Now we have to do the deployment or delivery. So here, instead of giving direct access to Kubernetes to the CI tool, what we will do, we'll install Argo CD in a separate Kubernetes cluster, or we can install it on the same thing. Only this particular Argo CD will have access to Kubernetes, no one else. So Argo CD will be maintained by its own admins. Now Jenkins, once it is pushed the image to Docker Hub, this image update will be registered in a new repo where all the config files will be there for the particular app. So this Argo CD app will be continuously monitoring this repository. It doesn't has to do anything with this code repository. Only this config repository. So here, in case the replica count is 2 and the deployment image is, let's assume it may change from v1 to v2. This will be same. So here the replica count will be 2, but the image tag got updated. So Argo CD will be continuously looking after this repository. Any change happens, then it will make sure that this change is reflected to Kubernetes. So by this, the CI tool doesn't have direct access to Kubernetes. Only these people will have access to Argo CD, and of course they have access to Kubernetes, but they only use admin access for particular tasks, and after that even it is revoked. Changes to be made in Argo CD, they can generate the again user ID with admin access and they can use it, or it is a different concept. It completely comes under Argo CD admin. Now the second case where someone logs to the Kubernetes and they try to change the replica count from 2 to 3 or 1 to 11 or anything. So Argo CD not only monitors this part, it also monitors this part. So it will see whether the replica count is 2 here and 2 here. If not, it will try to make sure that whatever is there in this Git repository available here. So it will again make from 11 to 2 or anything. It matches the Git repository. So this is the overall concept, how Argo CD helps us to make sure that the code in Git is matching with the end servers. Now, what will be the path for today's demo? I will be using a laptop with Linux and GitHub and GitHub Actions, then to Docker and a Kubernetes machine installed on EC2, and the same K8s I have Argo CD, and this is the flow. I don't do any test or scanning or anything. I just want to show you high level. I'll create a simple app and it will be pushed to Docker Hub. This will be one repo and this is called code repo. And there will be one more repo, config. So I'll link Argo CD to the config, and whatever image is pushed to Docker, I'll update the same thing in this config repo. So instead of using Jenkins, I'll be using GitHub Actions. Maybe you can take a homework or a challenge and try to replace this CI tool with Jenkins or GitLab CI and this Docker to JFrog or anything, Nexus. And here also you can change it to Bitbucket or GitLab, anything. It's up to you. I'll be creating a EC2 instance with Kubernetes Argo CD already installed in it. Let it run in the background. I already created two repos, one for code and one for config. Now I'll try to clone them into my local machine. And this is the config. With this code repo, I'll be using Express app and Node.js. You can use anything Python, Flask app, or Django app. For simplicity, I'll be using Express app. So if you don't know how to use Node with Express app, just try to follow the steps I'm doing. Node has to be installed on this machine, and copy this code. So I just created the Node app, and let's see. Node 3.5. So hello GitOps, it's running fine. Now what I'll do, I'll try to create a Docker image for that one. Before that, let me push this one to the Git repo. Mhm. Now let's create the Docker file. Nothing is running on my machine. No Docker images. So I'll build this image. That is the issue. Let's take another node image. I just created a container from this image. Now let's try to see if this works or not. Yeah, again, this is working. Now this is running from Docker image, not from the Linux machine. Upload this Docker file to Git repo. Now the code part is completed. We are yet to build the GitHub action, but before that, let's see what we have to give in the config repo. So here we have to ensure that this will be for a single application or for multiple applications. If it's for multiple applications, we have to create some directories. I'm creating a front-end app. So I'll be giving the basic structure for a Kubernetes deployment, which is a service and a deployment file. Now let's see my other code. So this has created a EC2 instance and given me some output. So I'll try to log into this one. So this part you can use any Kubernetes cluster. It may be Minikube or Kind or AKS or EKS or anything. You just need a Kubernetes cluster with internet access, because you have to access Argo CD and link it with GitHub. There should be some internet connection between them. And this particular code, it also generates a temporary key for me. So I'm using this temp key to access the EC2 cluster. This is my mission, and here I have Argo CD already installed and the CLI is also configured. So I'll go and get the Kubernetes secret command. So this will be the password for my Argo CD. Let it here. So directly if I give this one, I'll not be able to access anything because I am running it on port 30903. So this is the Argo CD UI homepage, and the default username is admin. And once I log in, I'll change the password. So the Argo CD installation part is also completed. Now we'll go and concentrate on the config one. So for this config, I will try to create a deployment file. I've got to create the deployment first. Let's apply the front-end deployment. Now I will apply the front-end service. The front-end app is not coming up because the Docker image, whatever we have created, we did not push it to the Docker hub. So it will be some error status like image not available or any error. So let's fix that by going into my local machine and uploading it. So I'm just trying to show how the Kubernetes deployment works directly, like without using Argo CD or any other method. Just I'm trying to use that image. So here I don't have a token, so I'll create a token for the Docker Hub. See, I am showing all these steps so that you'll get knowledge. It's not like wasting your time or I'm just trying to show how each and every step can be done and you will get experience. Token. I'll be using this token. This is the step to create image, Docker Hub token, and then to push it. Now, if I go and see in my Docker account, I should see the image. So this is the image. It's less than a minute ago. If I come here now and try to see the image is uploaded, so the deployment got up. And this service right now is in cluster IP mode. So I'll change it to node IP. Node port. It has changed to 31092. So what I'll do, I'll come here and duplicate this one and 31092. Yes, I need to remove the yes here. Now, hello GitOps. This image is working fine. It has been uploaded to Docker Hub and the same image has been used in my Kubernetes cluster. This image is working fine. It is working in my local machine and I have uploaded to Docker Hub and then used the same image in Kubernetes cluster. So everything is running fine. So most of the part is completed. Now let's go and see how to use it in a config repo. So this is the config repo. And so what I'll do, I'll take this ML files. I'll use the same ML files. And I'll remove all the unnecessary things. Mm, and also I'll create a namespace here. Let's give it node instant front end. And then followed by service. So this is the service. And here I'll directly choose the node ports service. Well, let's upload these two files to GitHub. Frontend deploy.yaml and frontend service.yaml. So now again, we need to go to the code repo and create a GitHub Actions pipeline. So before that, I'll come here and delete this. So apart from Argo CD, the regular one, nothing is running. So if you don't know how to use GitHub Actions, just follow the code or copy the code whatever I'm showing and try to replicate it. As a homework, you can also do the same thing in Jenkins or other CI. On GitHub. Git commit. push. Okay. So I'll directly open this one now in the web UI. I'll create a new branch here and call it as dev. So this is the GitHub Actions CA file. So here there are a few steps. The first one is to check out the code, and I am skipping everything else like testing, scanning the code or anything just to speed up the process. So what steps we will take is check out the code, build the image, push to Docker Hub, and then do a image update in the config repository. Now this is the GitHub action script. So everything runs on a push to the main branch. And the first step is to build and push. So here I am getting the GitHub SHA, whatever commit SHA, and then there is a checkout of the code, and then the next step is to log into my Docker Hub account. And this is the Docker Hub username and password. I'll show how to add this one. And then to build the Docker image. So I'm giving a image tag here as a variable where it will get the Docker username followed by my repository and then colon build and then followed by the run ID. And I'll build the image tag and then I'll print it, and next step is to push the image to Docker Hub. So before this, I'll try to create this Docker Hub username in the settings of the code repo. Tickets and variables. Docker Hub username. And then Docker Hub password. You can give both under secret. So let me do that one. Docker Hub password. So this will use this token, whatever we generated. I'll remove this one under username and I'll give it as a secret, both of them. So now this is set. So I'll explain once again. We are only trying to download the code, log into Docker Hub and build the image and push the image to Docker Hub. As of now, this is the so under my account there is only one repository which we created manually previously, so it should create a new one. So I'll push this one to the main branch. Compare and push, bring from dev to main. Merge the pull request. It's done. Ubuntu latest. So it pick up a runner and now it's running fine. So all these steps are success. So check out the code, log into Docker Hub, it succeeded. Then building the image, it is succeeded, and then pushing the image to Docker Hub. Everything is completed. Let's go and check the. Here it created a new repository with image. So here I think I gave the name wrong. I'll fix it, but the main thing is the tag. It's followed by build followed by some number. It's the build number. Okay, let's fix this one. I'm doing everything in a fly, so you may see these issues, whatever I'm trying to fix it. So the first part is success that we can see here, like it's trying to download the repository and build the image, push it to Docker Hub. Okay, let a new action run. Meanwhile, what we'll do, we'll do the next step. So next step is to update the image tag in this config repo. So it is located in this repository followed by this folder, and in this folder it has to go here and update this particular image. So for this we need to again add one more step in the GitHub actions. Here the first step is build and push. Now we will add the other step, which is update the config file. So these are the update and config steps I have pasted here, and what this will do, this will again check out the config repo, this one, demo GitOps config repo, and then it is referring to the main thing. Generally here we'll also create a new branch and it will push to the new branch and someone will merge it to the main branch. Then only the code will be pushed to the GitHub. It is a continuous delivery kind of thing. If we want continuous deployment, like no middle person in the update of this Docker repo, sorry, this GitHub repository, then you directly go with main branch. So the next step is update the image in deployment manifest. Here what we are trying to do, we are using the same Docker username and the image build and everything. Then we'll try to go into this folder and we'll see if we are listing the contents correct. We'll list the image tag, and then using the sed command, what we'll do, we'll try to update the image tag in frontend folder and frontend deploy.yaml file. So for this I'm using my credentials, GitHub config and everything. And to push, I need to use my GitHub token. So here I'm using this command. So it has to download and again upload it back to GitHub. So for this we need a GitHub token. So for this I'm using GitOps token option. So again I'll come here into my settings folder and under secrets, here I need to give a token for this particular GitHub account. If you don't have this token already, we can come here and generate a new token. So here you can come and generate a new token. If you don't know, I'll create one token here. Uh, Demo only for 30 days. This one and this one is enough, I think. Click on generate token, copy this one and paste here. Okay. So let's try this one and see if it updates the image properly. If not, we'll troubleshoot. Come to dev, an APR. Smart. Previously there was only one step, now it will be two. So again it will try to build and push the image to Docker Hub. I don't think so we need the other two. I'll delete them. A new image has been pushed a few seconds ago and the next step has to be success. So this is the update config one and it also is succeeded. So we need to go to this part and see whether it's updated or not. Yes, this file has been updated here with the new image tag. So here comes the main part what you are waiting for. How to link this one to the Argo CD. As this is a public repository, I don't need to give any secret or anything. So I'll take this HTTPS GitHub repo, go to Argo CD and under settings, I'll upload the, means I'll give a connection to this particular Git. So I'll also create this in default project. It's successful. I'll go to applications and create a new app saying node app, project name. I can give default, sync policy to automatic and auto create namespace, prune self repository. It will be listed and refer to head and path is. So here comes the place where you need to select whether you want to go and check all the folders in this particular path or only this particular folder. So I'll give giving only this particular folder. I'll explain why later. And then it will be creating in my local cluster and namespace here. What did I give? Front end. The namespace is node app. As of now, it's not there in the cluster. Can So it is not there in cluster. So we are giving Argo CD permission to create this node app. On create. Okay. So this app is now syncing. So if I come here, it is 30905. So this will not be working right now. So hello GitOps. So everything is working fine. So if whatever changes I do in my code repo, there should be no middleman. Let me explain. So I'll go to index.js. So here it is hello GitOps. So I'll be adding 3 exclamation marks. There is a change in my code in the dev branch. I'll come here, add the text, commit and push, and then come to the dev repository. I'll click on open pull request, merge from dev to main. So generally this will be done from your team manager, project manager. So they'll merge it to the main branch, and then a new action should be generated. So here again 2 steps, build and push and update the config file. In this build and push we'll be having all these steps like testing, scanning of the code, dast, sast, all these steps. The build and push step is completed. Now the update config is running. If this step is completed, again this one will change the image tag. So this is the new image tag, and this should come and update the YAML file. But this has a default sync time of 3 minutes. So if you want to wait 3 minutes, okay, or you can use GitHub Argo CD webhook connection, that also we can do, or else we can come here and click on refresh. So as we have given auto sync, once we click refresh, everything will be synced and a new pod will be created. The old one will be deleted and new pod will be created. So come here, click on refresh. These are the 3 exclamations. So this is what happens, like there will be no connection between the CI tool. In case of here, it will be GitHub action. So GitHub will not have direct access to, is the CI tool will not direct have access to the Kubernetes cluster. Now this is the high level of what GitOps is. Like anything we do in the application code, it will directly push to Kubernetes using the help of, oh, why? Okay. Now I'll come here and we can see the node app is there. This is the node app. What I'll try to do, I try to edit the replica count from 1 to 2. A few seconds, a pod is trying to create it with the change whatever I have done, but Argo CD is maintaining this particular deployment, so it will try to terminate it. It's trying to terminating it and keep the state as only one replica. So if I really want to change the replica count to 2, I have to go to this config repo, come here and update this particular file to 2. I have created 2 replicas here. Again, come and refresh. Now it's creating 2. If I try to change it to 2 from 1, it will again create within 3 seconds. So it will again create immediately. So this is what's the advantage of Argo CD or Flux or any GitOps tool while maintaining the code to create deployments or any other files in any other resources in Kubernetes. I know this is very hard to understand, but this is what happens in real time. Now, the next step is to use either app of apps pattern or app set. It's a different concept. Instead of directly linking this config file to Argo CD, we will use app of apps pattern where multiple config files will be referred in a single app set repository, and that will be linked to Argo CD. I'll show you that in the coming videos. So if you understood or not understood, if you have any doubts or if you need more clarification, please let me in the comment section what exactly you need more. I'll try to answer them in the coming videos or next. Maybe I'll make a complete list of the doubts in the YouTube comments and I'll make a new video. So high level, this is what you need to understand. You need a code repo, you need a config repo, and you need the Argo CD. Also here, most of the time the config repo will be private. So you need to create a generate a token and then execute the token here in Argo CD so that the reconciliation will be fast instead of waiting for 3 minute sync window. That is another topic. And generally I upload videos in Telugu in this channel, but for this concept to go to most audience, I recorded it in English. So if anyone who wants the same thing in Telugu, please let me in the comment section. I'll try to answer them. Thanks and see you in the next one.